Hey guys, welcome back to Science Fun with Mike. I'm Mike. I got a really fun one for you guys today. We're going to be dealing with fluids, so stay tuned and I hope you guys learned something. Thanks. So our first lab is going to be density. And for the density lab, we're going to need olive oil or any type of oil, water, Alka-Seltzer, and food coloring. And to start, we're going to first fill up our glass about 2/3 of the way up with olive oil. Next, we're going to fill the glass the rest of the way up with water. Now you'll notice that the water will sink straight to the bottom, and that's because water is more dense than oil. Now you can add food coloring of your choice. I chose red. Don't really know why, just went for it. And you can just put a couple drops in there, but be sure not to mix it. And our last step is to put a tablet of Alka-Seltzer in, and now we wait to see the reaction. So the Alka-Seltzer and the water combined releases carbon dioxide, which makes the tablets of water want to rise up through the oil. And once it rises up, it's still denser than the oil, so then those droplets float back down. Once the reaction settles down and it's not really doing too much, you can go ahead and throw in another Alka-Seltzer tablet if you'd like. And you can watch this go again and again and again. So there it is. That's our first lab to make a little lava lamp just using some household items. So next up, we're going to do another density lab, and for this density lab, you're going to need olive oil, honey, dish soap, rubbing alcohol, food coloring, and water. First, we're going to combine a 1/4 cup of honey with a dash of red food coloring and a dash of blue food coloring to make our honey purple, and this is going to be the most dense out of all of our liquids. Now we're going to add this purple honey into a tall jar. Next we're going to add a 1/4 cup of blue dish soap. Now pour very slowly as you want the dish soap to rest right above the honey like I have here. Now we're going to add some green food coloring to some water, stir it to mix in the color, and then add it on top of our mixture. So far you can see the clear 3 layers with the honey at the bottom, and then the dish soap, and then the water. Next up, we're going to pour in about a 1/4 cup of olive oil into our mixture. Whoa, sick editing alert. And boom. Now this was my favorite layer because I thought it was the most see-through so far, and it just looked really cool. And the last liquid we're going to do is rubbing alcohol. So once again, we're going to do a 1/4 cup of this, and we're going to put some red food coloring in it this time, and this is going to be added on top to be our 5th layer. And boom, now we're done with our second lab, and you can clearly see all 5 layers there starting with the honey at the bottom, then the dish soap, water, olive oil, and rubbing alcohol. And the way that this works is that each ingredient is less dense than the one below it, so it allows it to stay above it. Alright, for lab number 3, we're going to be doing a viscosity lab. Now for this lab, we're going to need water, olive oil, syrup, and honey. And we're going to fill 4 glasses with this exact same amount of each liquid. We're also going to need a bag of marbles too. And first thing you're going to want to do is pick out 4 identical marbles. And we're going to be timing how fast it takes the marble to go through the water to touch the bottom of the glass. So I got my brother timing it to the side. The water took 0.11 seconds. Now the oil was also 0.11 seconds what we got. So pretty similar. And now for the syrup, it was a little bit slower because the syrup has a thicker viscosity than oil and water, which means that it takes a while for the marble to pass through. Now the most viscous of the liquids is obviously the honey, and you can see here it takes forever to go through. Now the reason is because honey has a lot more internal friction inside of it, which makes it hard for it to move around and for things to pass through it. Okay, for our 4th lab, we're going to be making a non-Newtonian fluid, and for this we're going to need cornstarch, water, and a large mixing bowl, and we can also use some food coloring if you'd like. First, add 1 cup of cornstarch to a bowl. Here you can add some food coloring. I did green, and then we're going to slowly pour in just a little bit of water at a time, mixing it each time we add some, and just gradually add more and more until you got rid of all your water. Now you're going to want to mix by running your fingers through the mixture very slowly, and you're going to be able to know it's done once it feels like water when you're running your fingers through it. And now we have here a non-Newtonian fluid. Now the reason we call this a non-Newtonian fluid is because Sir Isaac Newton in the 1700s declared the laws of an ideal fluid and called them Newtonian fluids. Since this disobeys all of those properties, this is non-Newtonian. When you apply a little bit of pressure to the mixture, it feels like a water almost. But if you hit it hard like I am right now with my fingers, it feels like you're hitting a solid and it doesn't splash at all. But you see, once I dip my finger in very slowly, that it looks exactly like any other liquid. And that's why we call it a non-Newtonian liquid. And lastly, we're going to cover Bernoulli's principle with Lab 5. And we're going to need a hairdryer and some ping pong balls. And what we're going to do is we're going to have a friend or yourself hold the hairdryer straight up and try to float as many ping pong balls as you can. And the way this works is that the moving air actually has a low pressure. So the low pressure of the hairdryer blowing straight up is surrounded by high pressure, which keeps the ping pong ball above the hairdryer, and gravity and the force of the hairdryer going up equal each other out, which lets the ping pong ball float as it does effortlessly here. Well, I hope you guys had fun. I know I sure did. And I hope you guys learned something new today and had a lot of fun with science, you know? So thanks for joining me these 4 weeks, and I'm out. Thank you. Bye.